All right, so hello everybody. Thanks for joining. Welcome to our today's EclipseStore fundamental training course. Um, Thank you for your interest in EclipseStore, and we have great new information. We will talk about this later on. So today we do it a little bit different. So Florian is our trainer for today. Florian is our CTO. So if you have any technical questions, please take the chance and ask as many questions as possible. So because Florian will be able to answer all your technical questions. And also please give us feedback. It's very important to ask questions. We prefer to do it interactive, so you can use your microphone to ask questions, but you also can use your chat to ask questions. We try to answer all of your technical questions, and also if you have concerns or any doubts of can this be possible, please use the chat. And by the way, this training course is recorded. So after training course, you will get a link to the recorded sessions. So please give us 1 or 2 days for preparing the recorded training, and then you have access. You also will get a certificate for joining this training course via email. All right, then maybe who is online? We have more than 50 people have registered for this online training course. Wherever you are, welcome, and maybe you can use the chat to write in the chat where are you from. So the last training courses were very international. People from various countries joined our courses. Always interesting to see where you guys are from. So please write in the chat where you're. Belgium, okay, great, nice. So someone Portugal, oh, wow. I think you have pretty better weather than we have here in Germany right now. So we have it's rainy, it's cloudy. Cloud is always good. Berlin, Germany, yeah, cool. Nice. So this training course is all about fundamentals, which means we start from the beginning, how to get started coding. And today we get started with not too much theories. We get started right now with jumping into the code. Florian will explain, of course, some basics and some functional principle, but then we'll jump directly to code and show you how you can get started coding with EclipseStore. And in the third hour, what is the fourth hour? 3 hours training course, right? So we will talk about some architecture use cases, and then you also can ask, we have some Q&A at the end, and so can ask your questions. All right, so let's get started. Florian, are you ready?
Yeah, I'm ready.
Awesome.
All right, so welcome from my side as well. Thank you for joining our today's training. And like Marco said, we have to change our habits. So I have to start because my time is limited today. Marcus will do the second part this time. So we jump right into the presentation. Just legal stuff. Oh, come on. So I'll do a bit of a rationale before to get a little theoretical part going to get all on track. What we are talking about here, what the EclipseStore is all about, and what the idea behind the framework was. In short, we had a lot of database projects back in the days, and we saw problems arising whilst developing these projects, and that's where the idea of EclipseStore was born. If you look at the classical database development approach, you always need, for example, two different data models. One data model will be your objects in the application, in your Java code, and the other one will be the data structure of your database, tables and relational ones, or key values, or whatnot. And there's always a discrepancy you have to take care about. You have to use a complex framework like Habermann in between, and that raises a lot of problems. First in the development side, second in the at the runtime, where you lose a lot of performance by just the mapping the framework has to do. So because the data has to be converted from tables to objects or JSON graphs or whatever format your database uses. And of course, not all arbitrarily complex Java object graph can be used to store data in a database like that. So you have to adapt your Java classes with a lot of effort. You're strongly limited, and you end up with a pretty flat Java object model. And most cases, you need an additional caching framework on top to the mapping framework like Habermann, and in the end, it leads to a highly complex architecture. And on top of that, you have to use a database query language or a Java query API, which under the hood generates SQL again to query your data. And for that, you of course need a highly skilled and experienced team, specialists of some sort, and database admins and the infrastructure to run all this. So, and this is where the idea for the EclipseStore framework was born. Because we said all this hassle just to store data, basically Java, the platform, delivers basically everything you need as a developer feature-wise. You have a vast ecosystem where you can use frameworks or libraries for every problem you've got. There's some solution out there. The only one missing as a pure Java library is to store data. You always need a third-party technology in the background, database servers primarily, and that's where EclipseStore comes into play. EclipseStore itself is just a Java library as well, and is a unique storage framework that stores the Java object graph natively, meaning similar as the memory, the JVM manages the objects on a heap. And this can be done without an expensive transformation to an incompatible data structure. So no more object relational mapping is needed. And this is the key difference to all the database systems, and provides a lot of cool benefits. So it feels like a native function for storing data, and you only need one data structure, the object graph. And so there's no more mapping needed, no more impedance mismatch, and no more loss of performance through this mapping. And this makes a pure in-memory computing paradigm possible. And you can max out the ultra-fast in-memory computing power of the JVM. The just-in-time compiler can be used fully, and every time the JVM has a new release, creates improves the performance, your application benefits from it, because we are talking just Java core stuff here. This is basically the idea behind it. and it's kind of a new paradigm. So the source of truth moves from the database to the application, and the application is in full control of everything. So you are not dependent anymore to an external storage service. So you can think inside the box again, just pure Java, designing your object model to solve your problem without thinking persistence first. Then add EclipseStore as a persistence layer, and you can implement your solution with good old poachers without any further hassle or restrictions, without implementing special interfaces or super types or even any annotations, just pure core poachers. So, but there's one thing you have to keep in mind through the paradigm change we are talking here. The source of truth moves here in an application with a regular database. The database is an external system, or even in memory, it doesn't matter. It's a different location where the data lives, and it's always the source of truth. And the application or users or threads or whatever you call it, or processes, have isolated user sessions accessing this data source. Even it is a cache in between, it doesn't matter. It's always, in the end, the database is the truth behind it. And you're working on working copies of your object graph. So you query your data and you get objects back. The objects will be generated out of the database's native format. And every user session, every thread, every application instance, or every REST service or whatever client is calling the database has always copies of these objects at their disposal. They basically live as long as the request and will be thrown away afterwards or put back in a cache, and the cache delivers the data again at the next request. The object graphs may not be in sync, for example. This is configuration dependent and adds a bit of more of complexity. But the benefit of it is you don't have to worry about synchronization and locking on an application side, because you're working on a working copy of the object graph. So you have to worry about concurrency on a database side for optimistic or pessimistic locking. So you have different responsibilities and different layers, like many other things, like authorization, for example. And yeah, various other duplicated stuff. You have validation on an application side, and you have constraints on a database side, or again, validation on a database side, and have from time to time you have to use double the stuff or develop double the stuff in application and as well in a database. So I see some people raising their hands, so you can unmute if you like and share your thoughts, or just use the chat. Or is it just a poll? Oh, I see. So with EclipseStore, the source of truth is now in the application. Your Java object graph living on a heap is your live database, and the binary target which EclipseStore writes to is just basically a binary backup of the data in your heap. And every single user thread, REST service, whatever, is always working on the same shared object graph in the memory. And that's a thing you have to keep in mind, because you don't have to worry about the concurrency on a storage target anymore, but in your application. But we get a solution for that, which makes it a lot easier. But this is always this one big difference you have to keep in mind. You don't have copies, working copies of objects which are just generated for a single request response cycle, but you're always working on one shared live object graph for all users on the same JVM. And that's the big difference when developing with EclipseStore as a storage solution. So let's see what topics we can cover today. We'll see how to create a data model for a sample application. Then we'll connect the storage layer to it. We'll see how we can create some data. We use Faker libraries just to get the data in for playing around. Then we see how validation works, how we can query data, bring in third-party libraries like Lucene for full text search, if you like. You can combine, of course, all the libraries to get the solution you need. Don't be afraid to mix up the libraries. You can use Eclipse collections or Google Guava libraries. EclipseStore will play along nicely. We have integrations in various different application frameworks like Spring or Micronaut. So you can leverage the full power of the Java ecosystem. Then the point I said, we have to worry about concurrency. I will show how we do on the application side. We have a upcoming GigaMap feature. We'll have a quick peek, and if time allows, we can jump into more complex stuff like type mapping, further customizing, look at the different storage targets and backup configuration, for example. So the first questions, what I mean by binary backup. The objects are serialized in the backup in binary format. That's right. So as we can see here, we have a binary target which we write into. It's basically any system which can take bytes. You can use your local hard drive. You can write into a cloud storage like S3 at AWS. You can write in different other server applications which can take blobs. Basically anything which takes bytes. And the format we use is a proprietary one, which is basically 99% the same memory layout as the JVM uses. And we serialize this data in binary form into the binary target. And this is the physical backup of your data. And the thing is, you don't always have to load the whole database into the RAM because we can use lazy loading. But we see that later on in the data model. All the binary data will live in a binary target or different binary targets depending on a backup configuration. But the source of truth, basically the live database you're working on is are the objects on your heap. That's the basic layout. Yeah. All right, if you want to play along, for the setup you need Java 21. Just copy the link in the chat so it's easy for everyone. This will be the repository I'm using to show the code. The repository consists of different branches. We will go through one by one, and afterwards, or you can clone the demo and code if you like. The demo itself uses Java 21. But in your application, the minimum requirement, if you want to develop your own application, is Java 11. So EclipseStore only uses Java 11, so you can use older versions as well. But of course, we recommend if you are able to use the newest Java version, then you can do so, of course. The library is available in Maven Central, though, so use your build tool of your choice. And the code you'll see in this repository is a smaller version of our big bookstore demo. I will show you in a few seconds. So you have to share a different screen. Yeah. So here we go. Yeah. So this bookstore demo on GitHub is a smaller version of our big one. You can find it at the official GitHub page. This bookstore demo is the big one, which has an UI layer and different other features. Where you can see how a EclipseStore application can be written. There are a lot of ways, of course, to do so. But this one also integrates different stuff like GraphQL for external access. We have Apache Jaxel as a scripting engine, so you can basically query your data from outside the application with the Jaxel language. And Vaadin as an UI layer and some more stuff you can look into. But for the workshop, I made a smaller version of it, so we can go through the code branch by branch and see step-by-step how the application can grow. So if you start at the master, of course, we only have a POM in my case. It's a Maven configuration where we see we just have to add our EclipseStore libraries. What I use is the storage embedded. That's where the storage engine lives. We can bring in the storage embedded configuration where we can use external configuration files. But more later on to that, we have special type handlers. That's not a must, but we bring some optimized type handlers for JDK collections. And we bring in the monitor Java Money API for money data types, some Graph stuff, and some logging. So basically, standard configuration like always in Java, bring in your dependencies, and you're good to go. And like I said, we're using Java 21 here, but the minimum requirement for EclipseStore is Java 11. So just have to monitor my chat. There it is. All right, so let's switch to the next branch here. Data model. And here we see a simple data model of our sample application. So this application mimics a bookstore chain, which operates several bookstores around the world, depending on a fake data or the demo data configuration. You can use as many shops and books and customers and purchases as you like, just to get familiar with technology. So let's look at some purchases. As you can see, bigger. These are plain purchases, so there is no implementing Java IO serializable, no special fancy superclass, no annotations, no nothing. Just plain purchase, and that's how you can develop your applications. You can bring in external libraries and use these types as well, like we did with the monetary API. So you can use third-party objects as well. EclipseStore will persist them happily or play along nicely. And for, I'll say, 95% of libraries, EclipseStore can handle the types out of the box. But if you have special needs, special use cases, of course, you can customize the engine down to the last bit. If you like, it's an interface-based architecture, so you can exchange any aspect of the engine you like, or you have to. So you can use write optimized type handlers for specialized types for third-party libraries if they have special needs. But basically, just simple purchase and you're good to go. So if you think object graph, there's always an entry point in this graph, and that's where the object graph will be connected later onto the storage engine. There's always one single root object from where the persistent graph will start. In this case here, I just called it data. So this is our root, our entry point in our object graph. And then from there on, I did several segmentations with our shops part. So of course, we have our books in a separate type, our shops, our customers and purchases. That's one way to split up your application. You can, of course, put all your stuff in a root object, of course, if you like, or you can just split up your application depending on your concerns. So you got a nice separation, a better readable code, and that's what we always tell our customers to do, to get a nice readable code base. So for example, if you look in the shops itself, the shop internally has just an array list where all the shops live. It's, I guess, the most simple way to use to manage list data or batch of data. Of course, most people think in tables when they are thinking how to manage data. The equivalent would be collections in Java. Most of the time you will, of course, using lists, sets, and maps, but in kind of a different way than just a single list for each database table. But you can, of course, create a better segmentation in your data. Not only just flat lists everywhere, but a better segmented data structure, because you don't have to map it to tables anymore. So, and this shops list is a private thing and implementation detail, and of course all the stuff which can go outside to what the caller will see are the methods we are providing. These are basically fused to your data, and so you can hide the implementation detail internally, because all the caller is interested in are writing or reading methods. In this stage, only reading, of course. Writing will be added later. And that's basically it. So just hide the collections or the complicated stuff and provide basically like the access code to the outside. So if you the customers would be the next one. Of course, we can say, hey, we do have a logical unique ID in our purchase, which will be the customer ID for the customer, not to confuse with a primary key. There's no such thing anymore like a primary key or a foreign key. There are just references in the object graph. But if your object has unique ID in the data, so we can leverage it anyway and use this as an lookup key in a hash map, for example. So the custom ID will be the key, and so we can have a direct lookup to our customers, so we don't have to browse through all customers to find a specific one with a customer ID, but have a very quick lookup in a hash map. And that's one way to create lookup path through your object graph to find objects quickly. Because we don't have a query language anymore like in a database. Like we can say select customer where customer ID is 1, 2, 3. So we don't have that in Java. So we only can traverse our object graph. We can use, for example, streams to navigate through collections. But basically, you have to think in graph lookup path and how to get quickly to your object you want to find later on. And of course, mostly we'll look up the customer by its ID, so we can provide a customer of ID or get by ID method, which is just a simple lookup in a hash map. Otherwise, we can use Java core features again to browse through the collections like streams. It's probably the quickest way to do so. So how I'd recommend to generate the ID. So various ways. Most of the time, the ID is out of it's not a technical ID, it's a data ID. So you could use an auto increment value as well if you like. So just give a static current ID and just at the customer ID we say it's current ID and increment it up. So you get an auto increment value, for example. It's one way to do it, or you have the ID generated by different external factors, like if you have a book, the book has an ISBN number which is unique worldwide. So this one is given, but if you have if you want to use internal IDs for your application, an auto increment would be fine, or just a UUID is used as well. I don't think I have it in my sample code here, but it's often used in projects. Just use a UUID for that. And you can say it's a random one, so you got a randomly generated unique ID for this, and you're good to go. Yeah.
Okay. And if you increment, you would and the service, let's say, restarts, you would read the last ID or the highest or something like that if you increment via static.
Yeah, you have to store
Yeah.
the highest ID somewhere. Yeah, in
Yeah.
the graph.
Okay. Thanks.
For example, you can use a central auto increment registry and store single values there, for example. Yeah, but we never needed it, to be honest. In projects, we always had we probably mostly use UUIDs for that, or we have an external ID like ISBNs or so on. Yeah.
Mm-hmm.
But it's a lot of ways to do it. Yeah. All right, so we looked at our shops with simple array list. Then we had our customers with a map. And the next step would be to say we want to create multiple paths to look up objects. Because let's say we have a lot of customers and we want to find a customer by name. The customers or a collection which don't exceed tens of thousands or maybe hundreds of thousands elements, it would be fine to do it with Java strings. If you get into millions or tens of millions, so we don't want to load all this stuff always into RAM just to filter it, but we want to have different ways to look it up and maybe lazily load it later on after filtering. And that's where we can use multiple lookup collections, like in the books. This is only one way to do it. There are several ways to create different lookup paths to your objects. And the most convenient way, I will show you in the end, it's a new GigaMap feature where you can hide all this complexity in one collection. We provide, for example, lazy collections as well, which do lazy loading internally. But if you do it with Java core stuff, what we like to do is use redundant maps with different values as keys. So the books are not copied in these collections, but only their references. So you don't have duplicated data, only duplicated references. So it's not a huge memory overhead, but you get a good benefit, a big benefit. you have quick lookup path. So if you want to see, for example, what publisher published what books, it's just, again, a simple lookup in a map if you want to do so, or if you say, oh, we have 10,000 books max, feel free, just put all the books in one single collection, use a parallel stream, it's done in a milli or even microseconds, because it's all in-memory stuff here. So don't worry about two big collections on the heap. But if you go into the millions or tens of millions, I would recommend to segment your data by any key. Maybe you can do it by date. We can show it in the purchases. All the purchases which live in applications are handled by this map, which uses the year as key, and all the yearly purchases are loaded lazily, meaning only the most of the time, of course, only the purchases of the current year are on the heap, and only for reporting purposes or for taxing purposes, older purchases are loaded into the memory and sorted and or filtered. And if they are not needed anymore, the lazy reference manager, which runs in the background, will collect all the unused lazy references and remove it from the heap. So with this lazy loading points, you can control what data will be loaded eagerly and what data will be loaded lazily. Every time the application starts up, you'll see all the data from the root object on. In this case, our data object will be loaded eagerly until the engine discovers a lazy reference and will stop loading from there. And only if the getter of this lazy reference is called, the data will be loaded onto the heap, merged into the live object graph in the background, and you can traverse this object graph filter on it. But you don't have to worry to run into out of memory errors, because the lazy reference manager, which is running in the background, will take care of unloading the subgraphs behind the lazy reference again. So, and it does it by comparing the last timestamp when the lazy was accessed or used, and will unload the least used references first, meaning the hot data will stay on the heap automatically, and lesser used data, the cold data, basically will be unloaded first from the memory. A lot of people ask us, why do we have a hard-coded lazy reference in our object graph? It will pollute our code. Why don't you use annotations like this, for example? There are several reasons because why we have decided to not use annotations but a concrete type. First of all, if you use an annotation, the engine has per se no way to interfere in the loading process of the object graph. But we would have to use some kind of bytecode manipulation like Habermann does. And this bytecode manipulation leads to a lot of trouble at runtime. Mainly debugging gets harder, it's error prone, and the performance loss is there as well. And the annotation cannot be used at any given point. For example, if you want to just lazy load the values of a map, you cannot write an annotation at the generic part of a type definition. So you only could write a lazy loading point for a complete variable here, a complete subgraph. And so you're not so as flexible as with a concrete type. So, and these are the two main reasons we decided to use a concrete type and not an annotation for lazy loading. Okay, so now we have designed our object model. For now, just 2D data, writing will come later. And now let's connect data storage. So just switch to the second branch. And additionally to our data objects, you will see the books.demo class. This is, for this demo, the central point of the storage manager. In this case, it's just a static singleton. Of course, you get the storage manager in different ways, depending on what framework you are developing. For example, we do have a Spring Boot integration, then you create the storage manager as a bean or get it by default configured bean. But depending on what framework you're developing on, but for this demonstration purposes, I just made a simple static singleton. And this embedded storage manager is the connection between the object graph on the heap and the binary storage at your binary target. In our case, we just use the local file system, use a storage directory called data/storage in our working directory. We set the channel count to 2 and create a so-called storage foundation. Then we can configure the foundation further, and the foundation starts up a storage manager, which is connected to a root object. The root object can be gathered by simply calling storage manager.root. And how we create this data, we will see in the next graph, in the next branch. But first, I'll tell you some more about how we initialize the storage. There are several ways to configure it. The quickest way would be to just start up a default configured storage manager. And this one is up and running and can be used. If you want to do a more fine-grained configuration, you can use the builder pattern here and set properties. And if you want to do more fine-grained stuff, you can use the foundation. The foundation is basically a builder style builder pattern where all the parts of the engines are living, and they can be exchanged before starting up the storage manager by your own implementations for various aspects. Or you could use an external configuration like XML files, or we support property files, XML, YAML, and a few other types. And you could use as well the configuration layer of your underlying framework, like the Spring Boot application YAML file, to put your configuration. So all pretty basic standard stuff. So that's the life cycle of the storage manager. It started up at application start, at application exit. You can do a controlled shutdown if you like, and to get the data, just call the root method, and the storage manager will return the loaded root. So how to create some data? We go to the next branch, data creation. So if you look at the creation of our storage manager, you will see an added check. We say if the storage manager's root is null, meaning there's no data yet. We just create some data with a random data generator, and we'll store it. And this will happen on the first start of the application. And at the second start of the application, the root object will be loaded automatically. And we could create a simple main and see how this works. Just access the data method and trigger the initialization. And let's see what happens at startup. So the storage manager's root object should be null because there is no data. So the data will be generated, stored, and afterwards we'll have data living in our application. This could take a while depending on the settings. Here we are. We get our data. And you can see our collections are populated nicely with some random stuff. So, and we'll end the application. And at the next start, you'll see the root object will be populated because we stored data once, so no random generation is necessary. And it will be skipped, and the data will be at our fingerprints at the next start run at the application. And you can see the data is basically there instantly. We don't have too big a data store, so the data can be loaded very, very quickly. And if you leverage the lazy loading wisely, you can achieve quick startup times. And you can see without further ado, all the data is at our fingertips. There's no querying anymore. You have to do only traverse the object graphs, call a simple getter of your lazy reference, and that's all you have to do to access all the data living in your data store, your database. The loading in the background, the attaching to the live object graph, the finding of the right references, the integrity checking, all this stuff is done by the engine, fully automatic in the background. And you just take care of the application and don't have to worry too much about the data storage stuff, only traversing a graph, calling a simple getter, and later on when we write data, it's just a simple store method, and that's all you have to do to get a persistent data storage. All right, so changes. Oh, let me see. Right, so we have some random data generation, and I think you're already on the right branch here. So if you look at our books, for example, shops, yeah. So you see our code base is growing. We don't have reading methods only. we have write methods as well. So we can add shops to our shop manager object here. What I did here is we could use an overloaded method. Mostly you won't need this, but this is just for demonstration purposes. Basically, you would use this bookstore singleton, the storage manager singleton, to persist your data. But in our case, we added an overloaded method where we can hand over a custom persister. And this storage manager we created in a bookstore demo class. The embedded storage manager is a persist that implements this interface. Or later we will see we can build custom transactions, create a bigger span, persist more objects at once. And therefore we could hand over a transactional persister over there and call the commit method later on. So these are two different ways to persist data. Just use the storage manager, call the store or store all, and create automatically created transactions, or create custom transactions by yourself and hand over this transaction object instead of the storage manager and persist with this one. And it's always just a simple store, and that's it. One thing you have to keep in mind, of course, you have to store what you've changed. And the biggest thing most people do wrong at the first time when working with EclipseStore, they say, I add a new shop. So I just store the shop, but this would be a no-op in a storage, because what you've actually changed is the shop's collection. You added a shop to the collection. Of course, the shop object is new, but if you store the collection itself, the engine will see, I store the shops, and it will store only the new objects in the shop collection itself and the new reference in the shop list as well. Meaning, it will update the shop's collection in the storage, meaning it adds the reference of the newly added shop plus the newly added shop itself. That's what this default store method does. It's a lazy storer. It stores only the object you handed over and the changed objects which can be reached from this shop's collection. So if you add stuff to your collection, what's changed is the collection itself. So you store the collection. Of course, if you change the name of a person, you don't store the name, you store the person, because the person has changed. The reference of the string in a person is changed, and therefore you have to store the person itself. So store what you've changed and you're good to go. And this store method inside is a transaction which is a all or nothing blocking operation. So if this method returns, you can go sure that the changes are physically written to the storage target. Of course, you can use frameworks to get a non-blocking operation or use executors for that to achieve kind of a eventual persistent, but this is a full persistent asset transaction. So where's my chat come? So I see we have some questions. All right. Yeah, of course. If you have microservices, meaning you have multiple instances of your JVM of your application, then an auto increment in one application doesn't make any sense. So you have to rely on a different way to generate IDs or use UU IDs instead. If you want to create unique IDs in your object graph, you don't need it because we don't use, you don't need primary keys anymore. Yeah, and of course, microservice topic, if you want to scale your application. The library itself, the open source part of EclipseStore, it's a single JVM approach. So meaning you can take care of a persistent state of a single JVM. If you're talking scaling your application to mirror your JVMs to scale horizontally, this is where the cluster solution comes in. That's the enterprise part of the solution, and this one takes care of the replication of the nodes fully automatic in the background. So you don't have to worry about synchronizing the nodes. It's done by the framework in the background. But this is a topic for the other workshop. What we do today is the core of the engine, the open source part, which is only for single JVMs. Of course, you could use it in multiple JVMs and can send the changes by yourself with Kafka or whatnot. But the merging, you have to take care of merging the data and take care of the conflicts. Yeah, right. The enterprise part is not open source. Yeah. But I think Markus will tell you more about the various frameworks and solutions we have later on. Yeah. All right. So where have you been? So like I said, you bring in new objects into your graph. You add objects to a collection. You change properties of an object and so on. You have to tell the storage that the object has changed by a simple call to a store method. And the delta, the changes will be written to the binary layer and can be restored at the next startup of the JVM. And that's all you need to know about storing data. That will be sufficient for 99% of the time. If you want to store more objects at once, you can use the store all method, which takes an iterable or an object array. And so you can store multiple objects in one single transaction. So sounds pretty easy in the first step. These are the main benefits in my eyes if you compare this application to developing with an external database system. So you don't have to worry about mapping your data back and forth to different structure like tables or JSON or whatnot, and you don't have to use SQL or any different other query languages like Cypher or whatever database dialect you're using. Just stay in core Java. You can leverage the power of the JVM. You can bring in third-party libraries from the Java ecosystem. And all EclipseStore does is taking care of the persistent state and restoring the data on the heap on demand. And this is an elegant and easy way to add persistence to your application. So small point would be in the validation part. So if you want to add validation, if you have a database, you can use constraints or use validations on the client side. And it's always the best thing, of course, to validate the data before you bring in the data at all, maybe at the REST endpoints of your application to validate it there, or of course you have to validate it before you say you call the store and make the change persistent. And since we are on a JVM, we can use whatever framework or library we want to use to validate stuff. These are simple examples. For example, we can use the require non-null, for example, of the Java util objects. Helper methods, we can write our own validation, like an ISBN validator. This is simple stuff. You find validators for basically every data type you can think of on the internet in some library. You can leverage JavaX validation, Spring validation, whatever you like. Just again, think Java core. I think Java ecosystem, bring in the library you want and validate with this before you store the data. And that's all you need to know about validation again. Very simple, stick to Java core and you're good to go. So not, no rocket science regarding validation. So as I can see here, we don't have a Java core poacher like string or a custom written poacher like ours here, the publisher. We have the monetary amount. It's a third-party library of the Java Money API. Just bring it in and EclipseStore will store it happily and play along without any further configuration. It just works out of the box. So don't be afraid to use the libraries you like to use anyway. Right, so for validation, and next would be how to query your data, since we don't have any query language. So there is no SQL anymore. Well, the JVM doesn't have a query language per se. How do we effectively query our data? There again, just think Java core. We have different predefined so-called query methods in our project. Let's look at some of them. You'll see in our demo, we have our data object, and there we have, for example, our books, and let's say how many shorters we will have in our books. And just print them out on the console. So we got 3 shorters, or some more complicated stuff like our purchases with want to compute the bestseller list of the current year. And the bestseller list returns book sales, which consists of the book and the sold amount. And we will see it in a console. The book, of course, consists of different properties, and the amount is in the background. You see it's a very small amount of data because we only sold 5 books, 14, 17 for the bestseller. But you see you get the gist. So you can write arbitrarily complex, let's call them queries, but we don't have to use a query language anymore, just Java core stuff. And by this, we can leverage the functional side of Java, of course. We can, let's say, write basic functions which compute stuff by a data segment, in our case by a year, and then we hand over a function which takes a stream and returns an object. And this function here just calculates the bestseller list. By grouping some stuff and using basically just Java Streams API to group, aggregate, and filter data, and sort, of course. So these are the four main features of the stream. You can filter them, you can collect them, you can aggregate them, and you can sort them, sort your data. Basically, like you can do with SQL as well, but only in Java core. You can leverage the functional programming style if you like. If you like, you can use just for loops and use if-else statements in between, if you don't like Java streams, or use a different library of your choosing. There are several other connection libraries out there which may offer different ways to filter and select or aggregate data. So you can use this as well. But in the end, there's no querying per se anymore, just Java core stuff again, aggregating, filtering, and sorting data with the Java library of your choice. So these are the most the more complex stuff, which computes multiple things depending on the input. But if you look at the more simpler stuff, the books, we do have, if you want to check what genres do we got in our books, or what authors, since we have the lookup maps, like I showed it in the beginning, where all the genres live as a key. You don't have to traverse over all books and aggregate all genres and group by genre and return the genres. Just return the keys of the map, and you get all the genres living in the books we've got. And so that's another benefit of the lookup maps we can use to aggregate the properties of the element living in the collections to get a lookup for aggregated data or for grouped data. So as you can see, again, this stuff is implementation detail. The caller doesn't worry about how we manage our data internally. He just wants results like the bestseller list. You won't see any list at all, just get the result. And so you can protect or hide the implementation detail from the caller in a nice fashion. All right. So Java itself is, especially the streams, or if you use parallel streams, is a mighty quick way to filter or traverse data, especially if the application runs for a while and the just-in-time compiler kicks in and optimizes stuff. It can filter or traverse really huge collections in matters of milli or even microseconds, depending on the hardware you've got. And most of the comparisons, like of course state comparisons or range comparisons or equality comparisons, are mighty fast. The only thing the other frameworks should be considered are full text search, for example. Full text search, you can of course compare strings in Java by comparing strings with contains, let's say, but this one is not the fastest, I'd say. The starts with and ends with conditions. So then there's regular expressions to do a more complex full text search, but that's slower again. But if you want to, you have a really good full text search performance, you probably should consider Apache Lucene, which is a de facto standard regarding a full text search in a Java ecosystem. Every other Java indexing framework or indexing server uses Lucene under the hood. It's a battle-tested library, and it can be brought in with any without a huge effort. Just to take a quick peek at it, we'll see the full text branch. It's living in the books. Yeah. We bring an index. The index hides the Lucene implementation, and the index collects all the titles of the books, so we can do a full text search about the book title. And we see it here. We have a search by title method, which lazily creates an index, uses the Lucene API to fire up a Lucene query, and the index class itself will map the Lucene ID of the index back to our books, and so we can create a full text search with Lucene in the background. There are various ways, various ways to use Lucene. There are several kinds of indices, kinds of storage formats in the background, but this would be too much for this training. But you only really need it if you want to have a really high-performing full text search in application. If you find with normal performance regarding full text search, the Java core stuff is fine. But with Lucene, you have more features at your fingertips and a very high-performant full text search engine, especially if your strings, your text gets bigger. If you have a lot of bigger text in your data model, I'd really would recommend using Lucene for that. If you have a text-heavy application. Yeah. All right, so the code is online. Just copy it and use it if you like the index type here, which hides the Lucene implementation detail. You can leverage it or use the Lucene tutorial of your choice. Right. So now we have the big one, the concurrency handling. Because if we look at our code right now, if you look at our customers, for example, all this code is not synchronized in any way. It's not thread safe. We do write to the customers collection, and parallel executed code could read the collection at the same time right now. So we can get in trouble if you have multi-threaded applications, and let's be honest, most of the time we have a multi-threaded application to leverage the hardware we've got, and so far we have to worry about concurrency, of course, to protect our code base from getting into an inconsistent state. So there are several ways to achieve thread safety in application. The most low-level one, or the easiest one, I guess, is to synchronize all the methods which access your data by using the synchronize keyword. If you add the synchronize keyword to all your methods, you're fine. But what it does, it makes your application effectively single-threaded, because a synchronize keyword locks every time. It doesn't differentiate between read and write logs, of course. It doesn't know what the code does. So every call to the method would be blocking, every thread would have to wait for all the other threads to finish. So what it does, it effectively makes the application single-threaded, and that's not what we want. We want, because we don't develop a highly performing in-memory application and then only use one core to operate on it. So there has to be a different solution for that. And therefore, I recommend to use read, or differentiate between read and write logs, meaning we have to use reentrant logs. Reentrant logs differentiate between write and read logs. They are a bit of a hassle to use, in my eyes. And therefore, we provide a locking API which hides the complexity, and the only thing you have to tell or to leverage is to differentiate between read and write, and the rest is done by the locking API itself. So locking API can be used in different ways. Maybe let's look at the documentation for that. Okay. So you'll see the reentrant read-write log. If you would use core Java stuff from the JDK, you have to create a read log, do your stuff, and finally release the log again. This code is too much to add at any point in your code where you want to use logging. It's too much, so we provide an API for that. We do have a logged executor. The logged executor hides the reentrant log implementation detail, and the only stuff you call is write or read, and wrap the code around. And this how you can achieve read and write locking and in parallel read execution in your code base. If you don't want to see the logged executor as a field, you can extend from the log scope, which internally holds the logged executor, and then you only call write and read methods we inherit from the log scope, and that's a shortest possible way to achieve the locking by API in our eyes. So that's what the demo here does. It extends from the log scope, and the log scope offers the write and read methods. So you can achieve a read and write logs without too much code. And if you want to use an even shorter code, you have to use our Spring Boot application. So if you use Spring Boot, you can bring in the Spring Boot integration, which brings mutex locking. And the only thing you have to do is write add read and add write annotation at your method, and the integration will use aspect-oriented stuff in the background and wrap the code inside your method, inside the read and the write log, and that's how you can achieve the concurrency handling in your application just by putting annotations over your methods. But this is can only be done in a framework which uses aspect-oriented stuff in the background, which Spring Boot does. So we could leverage it. If we are in a non-aspect or non-CDI environment like just Java Core, we provide this API. This API is for free as well. It's in open source part. just extend the log scope or use the logged executor, call the write and read methods, and you have a thread safe application. And you can harden your code for a multi-threaded environment.
Florian, maybe a question in between.
Yeah, sure.
To the locking mechanism. So from my understanding, this would translate in a relational database word to a pessimistic lock.
Right.
Is that right? Okay. Are there some mechanisms to an optimistic lock, or would that be something you have to do your own?
We do provide a special API for this. For an optimistic locking, you would have to keep copies of the data in order to roll back the stuff, or to compare what's changed.
Mm-hmm.
And therefore, we have an API called layered entities. Just have a look in the documentation. So here we do have layered entities. Yeah. The layered entities is an API concept which separates the entity layer from the data layer. And if you add the versioning layer to it, this layer keeps arbitrary amounts of versions of the data. And so you can roll back and compare the different versions and achieve an optimistic locking. With the versioning context in between. And this one brings, for example, auto incrementing one, or you can use a versioning context with timestamps. And with this one, you can achieve an optimistic logging if you need to. Yeah. Pessimistic logging is, I guess, enough for most applications. If you need to use optimistic logging, we have this API for it. Yeah.
Cool. Seems convenient.
Yeah. All right. So this is the most inconvenient part, I guess, for the if you will, so the one downside, the one big downside of this approach to persistence, because you have the source of truth now in your application, so you have to do the thread safety stuff, the concurrency stuff in the application by yourself. But if you think of it, it's a small price to pay for the benefits you get. And by using the blocking API or the Spring Boot integration, it's as easy as adding a single method call to your code. All right. Yeah. The pessimistic locking in a multi-instance environment. Yeah, our enterprise cluster solution can do this because it's a single master approach. So we don't have distributed locks, which kill the performance. We only have to lock on a writing node, which is elected by the cluster itself. And only the single master will do the writing code and can lock on this node, and all the other nodes are only in reading mode. So you don't have to worry about locking at all at the reading nodes. And this is the approach we do in our solution. We don't have a multi-master yet. We are working on, of course, the future versions of all the libraries where we plan to use a multi-master, but for the current version, we have a single master approach, and so we don't need distributed locks. All right. So the next branch, when we look first, let's have a step back to our books. So like I showed you, we have multiple ways to achieve different lookup paths to our collections. But it could be a bit of a hassle. So you have to put all the objects into all of your collections. If you add a book or remove a book, you have to do it in all collections, of course. So it's a bit error prone, and the code isn't as nice to read. And the other thing is, if you don't achieve a good segmentation of your data, like you put all your purchases in business years, like here. Here, you have a map where you can segment by date. That's you could handle it. But if your collections get too big, let's say we have hundreds of millions or even billions of objects in a single collection for some reason, if your design needs to do so, it can be quite slow to filter the data, because in order to filter your data, you have to load it. So you have to instantiate all the collection or the whole collection if you want to filter on the whole collection. So it has to live on heap in order to use Java streams to filter the collection. Of course, if you can pre-select stuff by lookups in a map, you can only load the purchases of a certain year and then filter on this. But if you load, let's say, all purchases because you have to do some reporting over the last 10 business years, it could be a reason to slow down the application. Of course, if you use big reporting, which goes over several years, you don't worry about performance too much. But there might be scenarios where you have to filter through huge amounts of data, where performance is crucial, and therefore we introduced a new type of collection, which brings an index. The index is living off heap in your JVM, and you can query this index off heap, and only the results of the query then will be loaded lazily onto the heap, and you can traverse the objects on the heap only for the results. So, and the lazy loading is completely hidden in the implementation, and the collection is designed to hold huge amounts of data. It is not limited by the int max value, like the array list, for example. Array list can only keep 2 billion records, because it uses an array internally, and an array can only have integer max value elements, meaning 2 billion and some. But we call it gigamap, uses internally segmented, lazy loaded segments, and all this implementation detail is hidden. You just use it as a normal collection. You can query stuff on a gigamap off heap on an optimized bitmap index, which operates in microseconds, even for humongous amounts of data, and then you load only the results onto the heap. Let's see how this looks. We did it for the books again, and all the collections are gone, and the only thing which is left is one gigamap typed to a book. We added some indices for indexing and querying data. And it can be used basically like a default Java collection, like an array list in your code. You just add stuff and you store the map. The map brings an own store method. Of course, you could say the persister store map. It's the same basically. And the map itself knows what's changed internally and only stores the changed segments and achieve so the maximum write performance, because only smaller internal segments have to be stored instead of the whole collection. And that's one of the big benefits of the gigamap, the write performance, and of course the read performance, because the filtering is done off heap on an index, and then only the necessary data is loaded onto the heap. And this can be achieved with the indexers. These indexers are just plain Java stuff again. We bring indexes for the most commonly used types, for all the numeric types, for all the date types, for strings, for UUIDs, and for collections. And if you want to index custom purchase, of course, you can do this as well. So on the index, not only predefined types can be used, but custom types as well. And the only thing the indexer has to do basically is to extract the value which should live on the index. So the ISBN 13 index gets a book and returns the ISBN. And this value will live on the index and can be queried off heap. And this is done with every index you like. Just extend one of the abstract types. Index string, we got index for basically every common type. Like I said, Boolean, all the numeric ones. We got datetime, local datetime, year, month, and so on. And for multi-value, you can index sub-collections if you want to do sub-queries, like you do a join basically in SQL. So you can index not only the first level of your graph, but you can index arbitrarily deep in your object graph. And this one can be used to create a huge index. And the cool stuff about this index is, since it is managed off heap, not on heap, the operating system can page it to the hard disk. So if you have really a lot of gigamaps in your code base and a lot of huge indices, the operating system or the JVM doesn't run out of memory like it would be on a heap. But the operating system will page the data out of the process onto the hard disk and can be restored anytime. So this is another cool feature. And the queries are done by a Java Core API again. So no especially new invented query language is necessary here, just Java Core stuff. And we will see here the indexes we define can be used to create conditions, and the conditions are the standard conditions you get in every query language. So you have comparing stuff, create equal for the numeric stuff, between filters, the common date filters like is before, is after, and so on. And the same works for multi-value indices as well. So we can filter in a sub-collection as well. If you want to say, I want all the books which have a certain author, you say where the author index is Stephen King, and you get all the books by Stephen King without declaring any joins or any referential hacking or whatever. It's done by the index logic under the hood. And you can basically create a complex filter by calling a simple method in an API. So this map query method will return a result object, and this result object can be traversed by several ways. Either you create a stream out of it, you can create a list, you can create a list with a limit or by paging, you can create a set, or you can just it's iterable, so you can iterate it in the loop. if you like. So it's a very versatile API, and is there to manage big amount of data. So if you have really huge collections, you wanna go through the hassle to segment your data by splitting it up into different maps or segmented or cascading collections. You can use the GigaMap for that. So the GigaMap is about to be released next week. The final version, it's currently not open source. It's not finally decided yet if you open source the code. But you can try it out right now if you like. The public beta is running since November, I think. So it's part of the beta version of the Enterprise Edition. If you can't wait until next week, I just put the link here. Just register for free, and then you can get access to the repository, and you can play around with it. And the final release will be next week for the GigaMap and 1.0. So much for that. I'll still have a bit of time for further topics, or if you have questions for the stuff I showed you, we can use the rest of the time. Yeah, this repository is only the example one. Like I said, the code isn't open sourced. It's not finally decided of if the code is will be released open source. Yeah, you had this link. Just create a free account, and you can use the condition. An extension for Quarkus. So we used to have a Quarkus integration for the predecessor, the microstream framework. But after we moved the project over to the Eclipse Foundation, we had to separate stuff, and the Quarkus team didn't have the time to port the integration. For now, we do have a Spring Boot integration, one from Micronaut, one for Jakarta EE CDI, Plain CDI, and several other. I would have to look it up. I'm not sure right now if the Quarkus is up to date with the EclipseStore integration we offered them. Yeah. See. Yeah, of course you could use the CDI integration for this. Yeah. Yeah, the CDI integration should work. Yeah. But I would have to look it up.
I think so too, because Quarkus implements the CDI specification.
Yeah, right. Yeah. All right. Yeah, good starting point. I would suggest if you want to start out or play around with the framework, of course, the documentation, our GitHub repository. Yeah, in the store repositories, we have some examples regarding several aspects, like several file systems, like yeah, basic loading or small aspects of the engine. These examples are linked in the documentation as well. So if you read about a certain topic, the example is linked, so you can look at small pieces of code. But if you want to see how an application can be designed from scratch, just take a look at the bookstore demo or the smaller one, which I used in my presentation. And there you can just fire up this application, put in some example fake data and play around with it and get a feeling how the engine works and how you could use it in your projects. Yeah, so that's where I would start. And of course, we got several stuff online at YouTube as well, good tutorials and different talks about this topic. So, and if you have, of course, ideas, join the community, join our open source project, bring in ideas, and or contribute code as well as you like. If you have ideas for integrations, we have open ears for that. So contribute if you like, and feel free to start discussions, ask us stuff at the GitHub repository as well, or on Stack Overflow. These are the channels we are monitoring, and we can get back to you the quickest way possible. Yeah. All right, so if there are no questions, I would hand over to Marcus. Let me see. Yeah.
Maybe another question: what are some features of the Enterprise Edition, or is that something Marcus is going to talk about?
Yeah, Marcus will talk about it, and the two core features, of course, are the first one is the gigamap itself, the big collection with the indexing and the replication cluster. So this cluster is coming with an infrastructure layer. We have currently integration for AWS or for on-prem. And in the background, there are several libraries running which take care of the replication of the data. And the application could be developed basically like a monolith. And the enterprise cluster takes care of the replication stuff and for the hardware stuff underneath. I think yeah, AWS and on-prem are the current targets we support. Yeah.
Thanks.
Yeah, until Marcus is ready. One topic we get asked a lot, just to be mentioned, is how we handle class changes. So of course, a lot of every application has a version 2 or classes change over the lifetime of an application. and we do handle it in with a technique called legacy type mapping. And what we do is we compare on demand when the object will be loaded onto the heap if the class has changed compared to the format in a binary, and to the conversion of the object to the newer version, to the current class version, on demand. So you don't have to rewrite all your complete storage by scratch, but the engine will convert the data based on automatically or user-defined mapping, and makes it possible to manage the evolution of classes. So it doesn't matter how many versions you have of a single type, because the legacy type mapping manages a so-called type lineage in the background and maps from version 1 to version 2 to version n. And so you can change your classes like you want, and the engine can cope with these changes. This is an important part as well. This is basically a part of the serializer, which is part of the storage engine, and the serializer takes care of the evolution of classes. Yeah. So, interesting question of your friend there. Yeah, the common mistakes. Yeah, I think that the biggest mistake people do when beginning with EclipseStore is thinking like developing an application with a relational database. They are thinking in tables and looking for solutions in MicroStream like JPA or Hibernate has. You have to think it from the different sides. So you don't think database, you think Java application, and then you add persistence. So design your application not thinking in flat structures like tables or documents, and therefore getting a better start for your object model design. This is the first big mistake beginner make, and the second one I showed in the code is to store the wrong object. So if you keep in mind the one sentence, store what you've changed. So if you add an object to a collection, what you actually changed is not the new object, but the collection itself. You have to store the collection. This is one of the biggest beginner's mistakes as well. And of course, the concurrency handling. But since we're offering this locking API from version 2.1, it's got a lot easier to handle concurrency. And or if you use a Spring Boot integration, these are the common pitfalls of the beginners, I'd say. Yeah. Example for object migration. I think there should be an example online. I don't have an example in my code, unfortunately. I would have to look it up. Yeah. Now we have examples for the legacy type mapping somewhere. I just can't find it right now. Best would be if you just easiest way to ask a quick question in the discussions at the repos, then we can link a example with the code. Yeah, there are several aspects of the type migration. Of course, you have a structural change and you have a type change. So you can handle both. So let's say if you add a new field or rename a field or remove a field, you can handle it by a simple mapping, field mapping. Or if you have complex changes, like let's say you split a field called name into two fields, first and last name, then you can do this type or structural changes as well. These are the two aspects of the type migration to the type version. So if you say you have a local date, but you need more better resolution, and you have to change this to local date time, you can add a default time to this new field as well, and keep the date part, just for a simple example.
Mm-hmm. And as I've seen, so the type mapping you define, I had a quick look at the docs. It's like you can do something like CSV files, right?
Yeah, that's one way.
Yeah.
You can do it by code as well. Just provide a map with I think that the key is the old version and the value of the map is the new version. Or you can provide a simple CSV file, and that's what we like to do in our projects. So we don't pollute the code base too much, but we have the migration basically documented in the Git repo as well, by versioning this CSV file. And yeah, it's the best readable way to do it.
Yeah. Okay. Thanks.
So yeah, backup is another thing. Yeah, several ways to do it. One thing is you could leverage the backup functionality of the underlying storage target. If you say use S3 on AWS, you can use features of S3 to replicate the data or to back it up. Or what we provide are two different backups. One is a full backup, which can be run in a cron shop once a night, for example. And this the backup can be written to different file system or file target. Or we have the full backup and the continuous backup. And the continuous backup is basically a clone as well from the original one, but it's written continuously at every change to the storage. Basically at every store call you do. And the backup can live, of course, in a different storage target. So you can have the live storage in a mapped drive on AWS and the backup on S3, for example. Yeah. So you can split it up into different file systems or storage targets. All right, so I'd say if there are no more questions, I thank you for joining. Unfortunately, I have to leave now, and let's take 5 until Marcus is ready, and then we can continue. So hope I see you somewhere at JCon maybe, or different conference, or we can read each other on our GitHub repository. So see you and have a good one.
Thank you, Florian.
Thank you, Flo. And I like to suggest a short break for 2 or 3 minutes. Then we continue. So you can grab a coffee or something like that, and then see you in 3 minutes. Thank you. Okay, let's get started. So with the second part, um, excuse me, which actually is the first part of our training. So sorry for that. Tonight we have to change our schedule a little bit because of time conflicts. All right. So I like to now wrap it up and repeat something again, more in theory. Let's talk a little bit about architecture and how does the functional principle work, and let's compare it with traditional persistence. I initially asked the question in the chat, who of you is absolutely new to EclipseStore? Please raise your hand. So this is not possible in the online meeting, unfortunately. But I guess most of you are new to EclipseStore. So and mostly it's helpful to explain again the functional principle and to compare it with traditional persistence. And it's because most people who are new to EclipseStore compare it with a traditional database. So they are wondering like, is it a NoSQL database? Because obviously it is not a relational model, so it must be a NoSQL database or something like that. No, it's not. Okay, you're dealing with objects. This sounds like an object-oriented database, right? Oh no, it's not an object-oriented database. It's really completely different. Oh, you were talking about graph. This can be a graph database, right? Uh, yes, we're talking about graphs, but Java object graphs, these are not comparable with the graph database, so it's not a graph database. Okay, so it is not a database at all. This is very important to mention and to repeat again and again. So this is not a traditional database. This is just a storage engine for storing your objects. So again, the EclipseStore is an Eclipse project, obviously. So, but it was not started as an Eclipse project. Maybe this is also interesting for you guys. We are also a member of the Micronaut Foundation, and EclipseStore is part of the part of Micronaut framework. So we are contributing to the Micronaut framework. It's also a part of Halidon, which is a microservice framework, so driven by Oracle. It's of course open source, and we have a beautiful integration with Halidon. And here's the history of EclipseStore, and it is not a new framework, and we are now experimenting, and so it's not like oh, so let's see how it works, and maybe you can use it in production. It's really different. It's the opposite actually. So we started developing EclipseStore in 2013. So it's pretty old actually. So more than 10 years old. And the first production use was in 2015 in a huge project for the furniture industry in Germany, or actually for whole Europe. So we had to replace an old object-oriented database. It was too slow, and yeah, reports were too slow, and so we replaced it with a we built an in-memory high-performance data platform for the furniture industry, and it worked really well. And so we also had some other projects with in the military sector, but this is what we cannot talk about. And so this worked really well. And so then we had the idea, so we have to create a product, right? So, and then in 2019 we founded MicroStream and started building a product. And 2 years later we open sourced it, and then it became integrated with Halidon, integrated with Micronaut, and then we started the EclipseStore open source project as a officially Eclipse project. Why Eclipse? Eclipse Foundation. Eclipse mostly is known for its development environment. So we decided to move the code to the Eclipse Foundation. It's because of a lot of other great frameworks are developed under the hood of the framework of the Eclipse Foundation. For instance, the OpenChain9 JVM. This was initially an IBM project, so IBM donated the code to the Eclipse Foundation. It's now called Eclipse Open J9. And J9 is really, OpenJ9 is really super interesting for EclipseStore and fits great with EclipseStore. And it's because it has a high efficient memory management. The performance is great. In our test, it was faster than Hotspot, for instance. So, and of course, we do in-memory computing with EclipseStore. So the JVM is deciding. And by the way, if you use a new Java version, it will be faster than older Java versions. It's really interesting, and it's deciding for EclipseStore. So the latest Java versions are the fastest. So for instance, the latest Java version can be up to 25% faster than Java 11. That's really huge. So, and which means it's great benefit for you guys, because you build an in-memory database system, you build an in-memory computing solution, and the JVM will accelerate your application by doing nothing. You just have to renew the JVM, the Java version, and your application gets faster. It's just because of you changed the Java version. You can be for sure that the upcoming Java versions will accelerate your application by doing nothing. That's really cool stuff. All right. So please, this is really important for us. If you like EclipseStore, you should start us on GitHub. This is really important for us. It's because it shows interest in the project. So if you have the time and you like EclipseStore, give us a star. This will help us and give us motivation in developing further development of framework. And it's because everything is, of course, for free. So Florian has covered actually all important topics. So this, this is makes it a little bit challenging for me, but it's not a problem. So let's have a look and compare EclipseStore again with traditional storage to make it more clear. So here we have an architecture overview of a common Java application, and let's have a look inside the database. We can see there is obviously we have a server. This is, and by the way, this is now the biggest difference between EclipseStore and all databases. All databases on the market, I mean, not all, but most databases are server databases. Of course, we also have in-memory databases on the market, but mostly databases, or when we talk about databases, we think of database servers. So there is a remote server machine running, and then the database is installed on a remote machine. Of course, we need storage for storing data. So no question. Then we have a database management system, and we have memory. And this is obvious, but it's important. So because of memory is, so many people have concerns in terms of memory consumption with EclipseStore. It's an in-memory solution. Obviously, you need a lot of memory. Memory is expensive. A database can be cheaper, right? It depends. So it's because of, would you run a database server with just, so let's imagine there is an Oracle database and you run it with just 2 GB memory. Does it make sense? Or maybe it's faster if you run it with 32 GB memory, or even more, 64 GB memory. I mean, the more memory, the faster, right? So it's the same with database systems, because they also internally load data in memory and keep data in memory. They cache data in memory. So the more memory a database system has, the faster it is. And we can see there is also sometimes code, stored procedures, stored functions. And mostly I ask the audience who of you uses stored procedures, and mostly only some people raise hands. It's because of we are Java developers, right? So we don't implement business logic in the database. So it's because we don't like functions and procedures. We love object-oriented programming, so we implement business logic in Java, of course. But database vendors will they will tell you why not implementing code directly in a database, and it's because of it can be executed faster. Your code is closer to the data. This is important also for EclipseStore. Please remember these phrases. So the data are closer, or your business logic is closer to the data, and vice versa. It can be an advantage. But Java developers mostly ignore the hint. It's because of we are Java developers, right? So no stored procedures, no stored functions. We have Java. Okay. Mostly database system is a black box. So it was interesting to have a look inside a database. As soon as we implement code in Java, I've learned everything is great. Everything is fine. We love Java. Object-oriented programming, type safety, and in the IDE, code completion. Wow, great. Everything is fine. As soon as you store data, then mostly we are in trouble. So we leave the way of object-oriented programming, type safety, and so on. Why? And it's because a database system works fundamentally different from Java. It's completely different world, has completely different concepts. So this is the reason why we have, from a technical perspective, a problem here. And we call it impedance mismatches. For instance, the object model in Java is much more granular compared to the relational model. Subtypes are not supported in the relational model, and you cannot navigate through a relational model. It's impossible. In a Java object graph, you can navigate through a graph that's super easy. So for a relational model, obviously we use SQL and so on. So we have so many differences between the programming language and a database. And this is linked to a lot of challenges. And with the NoSQL databases, it is pretty much the same. So of course, they now introduce new data structure and different data structure, different formats. But they are all server databases. So they are also run on a remote server machine. They introduce new data structure or formats, but they are also completely incompatible with the Java object model. So for instance, a graph database is not comparable with the object graph in Java. So this is a proprietary database specific graph. And the challenge is you have now to adapt your classes to the graph, to the database graph model. And it's also the same with the old object-oriented databases. So this was the idea in the 1990s. It's because of the object-oriented programming languages. They were now leading, and so it was obvious we want to deal with objects, we want to store objects. Why not using an object-oriented database? Wow, great idea. So the problem was they invented their own object model because they wanted to be compatible with or not compatible. They want to be used with all programming languages, not just for Java. Hey, please, C++ users use us. Hey, please, Java developers use us. The problem was now they had to invent, they invented their own object model, and they were incompatible with the object model of Java. So same, you had to map your Java objects to the database objects. And then, of course, a database vendor wants to invent a product that is the boss in the infrastructure. So yeah, so we want to have everything. So implement your code inside the database. So that can't be replaced. So this is great for database. So they invented also their own subtypes and so on. So this was maybe a big mistake. So because it was slow, schema changes were really effortful, and so this might be the reason why object-oriented databases, the concept didn't work. And you cannot compare EclipseStore with an object-oriented database. So a lot of challenges, and of course, yeah, you can read in the internet. You find a lot of articles about impedance mismatches and so on, and the same with JSON databases. So yeah, you have to transform and generate JSON code, and vice versa. You have to generate objects. So this is also with JPA, Jakarta Persistence API, or previously Java Persistence API. The problem, it enables you now to store objects, but it just creates SQL code, and vice versa. A relational database, of course, will deliver a result set object, and it has to be and the Java object has to be generated behind the scenes. So you have object relational mapping behind the scenes through every single read and write, and this is very slow. This is mostly really doubles or sometimes triples your query time. So if you have colleagues and they are really database enthusiasts, that's really great, and it will tell you, I can't imagine that the database has to be faster. I don't think so, but probably, maybe. But keep in mind, the database can be fast, but behind the scenes, object has to be generated by an object relational mapping framework like Hibernate. And this will take milliseconds, sometimes 100, 300 milliseconds, so depending on the complexity of your objects. But this will double your query time. And this is the reason why database applications in Java are mostly so slow. And so normally when you use object relational mapping, then you need a cache, or you use a cache automatically behind the scenes. You use a Hibernate cache, second level cache, first level cache. That's great. So then objects or result sets are stored in memory, because in-memory computing is fast, right? But the problem is the objects are serialized into the memory, and when you access directly the cache, the data has to be deserialized, and this is also linked to latency. And so even if you read data directly from a local cache, it can be milliseconds, not microseconds, like we would expect when we have access to memory directly, or even nanoseconds, because memory is fast, right? So with Hibernate, it can be, or is mostly, access time is mostly measured in milliseconds, even if you have read data directly from a cache. So it is super slow in terms of memory computing. And the complexity increases because now you have to deal with cache configurations. So it's just because you want to store objects. And this is just a single node approach. If you talk about distributed applications, the complexity will explode. So now you have to there are further challenges. Let's say you start your application or your service multiple times, run it in multiple JVMs, so you have a distributed application. Now on one node, a user changes some data. What happens? This node will be in sync with the database. That's great. Problem, maybe all the other nodes are not in sync with the database anymore. It's because data is changed in the database. Okay, but it's not a problem because we can now change our cache, or you can change your cache strategy and put the cache between the application nodes and the database. And then we have kind of like distributed cache. So you can see the complexity increases more and more. And it's just because we wanted to store some objects. And if we have, we need high availability on the database, or we have high load on the database server. Maybe we want to have multiple database nodes, so then we use a database cluster, and then our architecture grows and gets more and more complex. So normally I'm super interested in hearing from you guys, who of you has such an architecture? You can write in the comment. So it's really interested. I'm really interested in hearing from you guys. No, I never had such an architecture. This is completely new to me. This is nonsense. Or yes, we have exactly the same architecture. So, and with microservices, we have not only one application that is distributed, we have multiple services that are distributed. So we have a little bit more complexity. And maybe we like our cache, and because now we have faster access to the result sets, but oh, I cannot search in memory. Search capabilities would be great. Can I search my my cache? Sometimes caches provide search capabilities, sometimes not. So it depends on the solution you use. But there are a lot of organizations, they have a great idea. They just add a search server. So why not using a search server in addition to that? So, and this is the reason why maybe use Elasticsearch for that. And another cluster is introduced, another complexity, another machines, and then we have the different database systems. As I introduced, we have different database systems. Why actually you have different database systems? It's because of they are built for a specific use case. So a graph database vendor would tell you if you have complex data, we are great. If you have sensor data, maybe a graph database is overkill. Just use a time series database. It's better approach. And a time series database vendor probably would tell you if you have sensor data, use us. We are perfect. If you have complex data like a graph, maybe a graph database would be a better approach for you. And now we have AI, we have now the vector databases. So, and this is the reason why we have multiple different database systems or database types on the market. And maybe you have a big application and you use multiple different database systems for different use cases, which means you have multiple systems, higher complexity, increases the cost, you have multiple machines and so on. So, and this is the reason why traditional database systems, they are always linked to higher complexity. You need much more resources. You need infrastructure. You need a lot of machines. So all of these boxes here are they show machines, so remote server machines. So a lot of CPUs, and they all, of course, require memory. So there is a lot of memory in use. So keep, please, and this is the most important thing. Keep this picture in mind. So there are a lot of machines, a lot of CPUs, a lot of memory. When we talk about EclipseStore, most people have concerns in terms of memory. So here we also have a lot of memory in use, but it's separated in different layers. So mostly hidden in layers. It's not in your application layer, obviously. It's in the data, it's in a caching layer, or it's hidden in the database layer. Okay, this doesn't matter. It's because of another organization will pay for that, so we don't care. But so keep this in mind. This is important. Now in memory data processing, and this is a completely different approach. So we, from the beginning, we believe with Java, we can do it better. Not EclipseStore is better, or the guys from MicroStream are the genius. No, we are not the genius, but we believe in Java. This was our point of view. Everything that's built in Java, anytime we use Java, it's better, it's faster, it's more convenient. So why not inventing or creating a storage with pure Java? Why not searching and filtering with pure Java? It's faster. Let's have a look on that. I love the Java logo, so grab a coffee. So in Java, what is great in Java? So it's the performance of the JVM. I mentioned this already. When we execute anything in memory, it's super fast. And so I often have discussions with customers, big organizations, and they not all use Java. But so we often hear the question, is Java really fast? I mean, I've heard it's slow. Oh, okay. Maybe so you heard it in the 1990s or so. When Java came up, now we have a JIT compiler, and it accelerates it optimizes your Java code, your bytecode. It compiles it to machine code constantly. If you write a C program, then your C code will never change. But the JVM will optimize our code constantly, gets faster and faster. And I remember a talk of Brian Götz said, the JVM with Java, we can really outperform C programs. So you can be faster than a C program with Java. So we talk about everything executed in memory. I've learned access to memory can be achieved in nanoseconds. Nanoseconds. This is 1,000,000 times faster than a database operation. Because we talk about milliseconds, right? So if we have a really complex operation in memory, we will expect this will take at least microseconds. Not nanoseconds, maybe microseconds. But even microseconds is a factor 1,000 compared to milliseconds, right? So we have great performance, and we have a great data structure. We have objects. We have object graphs in Java. As I mentioned, in databases, they focus on a specific use case, and it's because they have a specific data structure, like JSON, like vectors or graphs or objects. In Java, we have it all. We can deal with vectors. We can just store a simple list. We have collections. We can we can connect objects and collections. We can use inheritance circular references between objects and collections. We have everything. It's from the beginning. It's a multi-model data structure. Database vendors are keen on having a multi-model data structure to tell their customers we can do everything. In Java, we can do it anyway. All right. So that's a great advantage. We can do everything in Java, and we have a perfect query language. We have the Java Streams API. We can search and filter in memory, and check this out. How fast Java Streams API is. It's extremely fast. Even if you have gigabytes of data, even if you have terabytes of data in memory, and a complex object structure in memory, searching and filtering on this object graph will only take microseconds, which means it's compared to a SQL query, mostly between 10 to 1000x faster. It's the Java power. This is the JVM performance. It's really just core Java stuff. And storage is also interesting. As I mentioned, EclipseStore is not a database server. Here is an example with PostgreSQL and on AWS. If you buy a PostgreSQL database service in AWS, in my example, we have 2 CPU, 8 GB memory, 1 TB data storage. It will cost around $4,500. It depends on, they have different instances, of course, and it depends on the region. And maybe you will find a service that is $1,000 cheaper, maybe 3,000. I don't know. It's around. So my example is $4,500 per year. So now, of course, if you run multiple nodes of your database for distributing the load, high availability, something like that, then your price will double, triple, and so on. With EclipseStore, we can do it cheaper, and it's because of we have just a storage engine for storing the object graphs persistently on disk, and we can store it everywhere. So the simplest case is we can store it in plain files directly on disk. And by the way, it's also the fastest medium. I/O performance will be extremely fast. It's almost the performance of your medium. So it's, if you use SSD, I/O will be almost as fast as the performance of your SSD drive. The interesting thing is we only need storage, so we don't need a server. So for instance, we can use a binary object storage in the cloud like AWS S3, and all other cloud vendors have similar storages, Oracle Object Storage or IBM Blob Store, Azure Cloud Blob Storage, and so on. Pretty much the same. And the interesting thing is 1 terabyte AWS S3 costs only $300 per year, compared to, I had one node $4,500 for PostgreSQL, compared to $300 S3. That's cheap. So it's more than 90% cheaper than any database in the cloud. And you don't have to care for setting up the database, for administrating and so on. So it's fully managed by the cloud provider. So it's even cares for for uptime. It cares for even data center replication. Everything is included just for $300, depending on, of course, where the service is, so the provider and the region. So, and now combining the power of Java with the low cost, the low price of a cloud object storage is a great thing. So then the end result is up to 1000x faster queries and saving more than 90% storage costs. That sounds great. And by the way, we don't need a database server anymore. So no more computing resources. You can see it consumes a lot of CO2. So we can reduce the CO2 emission more than 99%. It becomes more and more important for organizations. This is a topic for your managers. But if you're interested in saving the planet, this is a good thing. But it's your decision. All right, so this is a rough overview about EclipseStore. And I like to repeat some basics now and show it and show some slides about that. You can imagine how the functional principle works. So the important thing is you can really build your object model freely. This is very important. Challenging is many developers, they cannot imagine what actually an object graph is. How should I build my object graph? I have no idea. So imagine you have a swing tree. Who of you is a Swing developer or used Java Swing 10 years ago? It's not interactive. What a pity. So it works. The functional principle is really similar. So you have a root object and all objects that are connected to the root object and they are that are reachable from this root object can be stored. And this is your object graph. And now you can just add objects. You can add any Java types. You can add collection and so on and connect all objects. They are connected via object ID internally. So you don't need a synthetic ID like the relational databases. So of course you can use such an ID. It depends on you, but it's not mandatory. And you can design now your object model freely. You can use all Java types. There are no requirements to your object model. You can use JSON blobs. You can, everything is possible. And the EclipseStore can store it. That's the cool thing. It can be stored, and it can be restored in memory when it's needed. And mostly just small parts of your object graph are stored. So you probably never will store your whole object graph, which means you would store your entire database. This makes no sense. So just store the changed objects, or if you add new objects, then you will store the new objects or the changed objects to your storage. And vice versa, EclipseStore can load your object graph in memory. In practice, only the needed objects, the currently needed objects are loaded into memory, and you keep the needed objects in memory. So you can have a 50 gigabyte data storage, but you have only 4 gigabyte memory. This will work. So this will work great. And of course, the more memory you have, the better. So if you have 64 gigabyte memory, use it. So it should not be a problem. Load the whole database in memory. If it fits to your use case, why not? I mean, other infrastructure have a lot of more memory in total using a distributed cache, a big database cluster, and so on. So this is very important. Use memory, but if you have not enough memory, this is not an issue because we have lazy loading. So again, we have here architecture overview, memory. We have a root object. Now we define a storage, and the storage can be almost everything. Your SSD drive, it can be also a blob store. It can be a mounted volume if you use Kubernetes. So everything they can store binary data. Then we right, so it's just we just need a root object, and that's it. So let's add some objects here, and then we store it. And as soon as you store an object by using a store method, we have seen, so Florian introduced the store method. EclipseStore generates a binary representation of your object in memory and stores the binary persistently into your storage. It generates a new file in the storage, and it will append the new file to your storage. If you store 1,000 objects, you will have maybe 1,000 new files in your storage, right? So even if you change data, if you change an object and you store it again, it will create a new binary representation and will be stored as a new file appended to your file storage. This is important. We never overwrite data in the file storage. We never overwrite data. And this operation, Florian mentioned it already, is a blocking operation. We have a transaction journal, which means this is an ACID transaction. So transaction safe. And we can guarantee that that data is really stored persistently on disk. Concurrency is a very important topic, and Florian introduced already the new locking API. We have introduced with the latest EclipseStore version. It now really simplifies concurrency handling on your object graph, because now your object graph is your in-memory database, and all users of an application or all threads of an application will operate on one and the same object graph. But with the new locking API, it's really comparable to a database, to the database locking. So really convenient. So when we start an EclipseStore application or a microservice using EclipseStore, then the engine will load the whole object graph information into the memory. So here we again have a root object, and then the whole object graph or all informations about the object graph is loaded into memory. But now it's super important. Please listen. Only the object IDs are loaded. No data are loaded into the memory. Only the object IDs. Then we have a kind of like indexed object graph in memory. So now the engine has all information about the object graph in memory. This is just some kilobyte of data are loaded into the memory. You as a developer, you can now define whether you want to preload data as well. So you can preload lazy references when on application start or not. So you can define all object references as lazy, which means no data will be loaded. If you keep your object as eager, then the engine will load the object reference initially into the memory. Very important. If you have not enough memory, use lazy loading. If you have a lot of memory, and startup time is not an issue for you, you can preload as much data in memory as possible. So if startup time is very important, don't use eager objects, use lazy objects, then objects and data is only loaded when needed. So this shows we load some objects lazy, then more and more objects are now loaded into the memory. And now you have full control of your lazy references. Actually, you don't have to care for memory management, and because everything is managed by the JVMs, you don't have to care for that. But you have full control of your lazy references, which means you can define a timeout, or you can just remove references from memory to save memory. It depends on you. There's a question in the chat. Potential issues might arise when using the local file system in production environment. So if you use the local file system of your application node, this is not an issue. So it's common to use just plain files. The EclipseStore framework provides you backup strategies, or 3 different backup strategies, and you can you can use these backup strategies to back up your files. And keep in mind, database systems as well will store data finally in the local file system. So in the end, all database systems also will store data in files. So it's pretty much the same. Searching and filtering. Okay, this is everything is told about Java Streams API. Schema evolution. Florian also mentioned schema evolution, and this was really one of the biggest challenges, and this was I think also one reason why object-oriented databases didn't work well, because of what happened if my classes change. Do I have to shut down my application, refactor the whole storage? No. We do it on the fly. It's super convenient. So if the object is loaded in memory, then the engine will compare your object, the loaded object, with your class. If something is changed in your class, let's say you change a primitive type, or you add a new field, you remove a field, or you will rename a field. These are simple cases and can be solved by the engine automatically by a heuristic. So you don't have to do anything. For more complex cases, you can define so-called legacy type mapping, and then you will store your object again. And it's stored appended to the file storage. And now we have 2 versions of your object in the storage. An older previous version of your object and the new version. Now you can configure the EclipseStore garbage collector and tell the garbage collector whether it should remove the older objects from the file storage or keep the older versions in the file storage for any purpose. It depends on you. This is so you can configure it, and so this is really very convenient. And in most cases, you will let the garbage collector remove the older object versions from your file storage. And then the garbage collector will not only remove older objects, it will also constantly clean up your storage and reorganize the binary files behind the scenes. So you don't have to care for, oh, there are so many binary files in my file storage. Oh my goodness. So this is not a problem because the garbage collector will reorganize it constantly. So think about defragmentation of your Windows system. It's pretty much the same. Now we have clean storage again. Great animation. So again, now let's have a look on all components delivered by EclipseStore. The Eclipse serializer, by the way, is the core of EclipseStore. So we serialize all objects directly to disk by using Eclipse serializer. We do not use Java serialization, and there are multiple reasons. Java serialization is slower than the Eclipse serializer. The Eclipse serializer can deal with all Java types. It can deal with really complex object structure, graph structure. So the depth of your object graph is not limited. Can deal with circular references, supports all Java type, and very important, Java serialization is very insecure. And Eclipse serializer is not. It works fundamentally different to all Java serializations on the market, and it's bulletproof. It's extremely secure in terms of deserialization attacks. So there's also an interesting report. Eclipse Serializer is a separate Eclipse project, so you can use Eclipse Serializer as a just a single serializer solution as well. If it's interesting for you, check it out. So this is the core of EclipseStore. And then we have the persistence framework. It's possible to store data encrypted and such. Yeah, of course you can do that. So you can use encryption as well. So the strategy. So the EclipseStore strategy was always from the beginning, everything that's available in the Java ecosystem can be used and combined. But we do not implement any features that maybe is not suited for all users, and encryption will slow down the performance. So maybe it's not 10 years. So we started 10 years ago. So security was a topic, but today, of course, it's more important topic. So it was not so important. Performance was more important. So we did not implement a standard encryption. So you can use everything that's available in the Java ecosystem, use it, and EclipseStore can store it. And it's for all other features, or it's the same with full text search like Lucene. So we don't have to invent a new full text search because Lucene is in the market. So use any Java API on the market, you can combine it and can use it with EclipseStore. So we have this persistence framework for storing objects, and a great question, and it's not a great question actually. So I asked the last 10 times at Java conferences. Now I think it's a stupid question. Who of you develops also Android apps? No one. But it's also Android apps are written in Java or Kotlin. That's great, and we have a persistence, or we have exactly the same persistence framework for Android as well. So if one day you are interested in building a Java app on Android or run a Java app, then you can use EclipseStore also on Android. And no, it does not run on iOS so far. All right, so legacy type mapping, we covered legacy type mapping already. File system garbage collector, file system abstraction, which means you can store your objects wherever objects can be stored. So local file system, mounted volume, wherever you like. We have database connectors, and this can be confusing because now we have, or there are database connectors, for instance, for MySQL. Okay, MySQL is a relational database. We talk about, we do not use a database anymore. We do not use the relational model anymore. Why the hell should we use MySQL? So it can be stupid answer is because it's possible. And it can really make sense. So we had a customer in the defense space, and they told us this is a great approach because now we can accelerate our applications. Awesome. But we are forced to use Oracle. Oh, sorry. That's a problem. No, it's not. It's because of an Oracle database or PostgreSQL database. They can deal with blobs. They can store binary data, right? So why not using a traditional database for storing your binary data in a database system? And it also is linked to trust. In the finance industry, we had a customer, and they were like, "Wow, this will accelerate our high frequency trading application tremendously. This is a game changer." But we cannot trust you guys. So because it's super important that the data is stored and we have the guarantee of the database. So we never ever want to replace our database and use EclipseStore as a primary database. Okay, this is not a problem. You can still use a database system. You can have the guarantee that the data is stored. So if you trust your database, no problem. You can keep it and use EclipseStore just as an in-memory data processing concept, and you can keep your database. And then it's, yeah, if you have more trust, if you have paid the license fees already, use it. And the interesting thing is, Oracle does pretty much the same. So they also have a graph database, and it's a graph API, runs on top of the relational database and stores binaries in the relational database. So this is a common, this is really a common approach. And if you want to use backup features of your database, and for whatever reasons, you can do that. So we can use traditional databases. You can also, we have also connectors for Kafka, for instance, so you can serialize your objects directly into Kafka. This can also be very convenient, so you don't have to deal with JSON objects, JSON serialization and deserialization. Just use EclipseStore or just the Eclipse serializer. It really makes sense and is super convenient. We have a REST interface for getting access to the storage data. But keep in mind, the storage data is not the database server you can now query. This is impossible because these are the storage data on disk, and this REST interface allows you browsing through the storage data, or have access to the storage data, but this is not a database server, so keep this in mind. And we have a graphical user interface, and we use the REST interface for enabling you to browse through the file storage, so you can see what data are stored on disk, and use it for searching, not for searching, just for checking out what data is really stored in the file storage. But also keep in mind, do not change. It's not for changing data in a file storage. So you will destroy your database, because whatever is stored in a file storage, it's done by the framework. So this same with the database system, you won't change data that is stored by a PostgreSQL database directly on disk. You won't change that. So you let the database system have access to this storage data. So keep this in mind. Okay, all right. What else? Are there any questions? Maybe this is everything is we have a lot of videos, so many people know already these basic information. Interesting, of course, it's EclipseStore is written in Java, which means it runs also with JVM languages. Maybe it can be interesting that EclipseStore can also be used with GraalVM native images. Normally, I would like to know who of you guys is using GraalVM native images. It runs. Wow, I have updated this slide. Great. So EclipseStore will run wherever a JVM is available. So I mentioned GraalVM native images as well. Microservices on desktops, on server, in the cloud, on containers. The only requirement is Java version 11 or newer, of course. And the newest JVM versions are the fastest. So also keep this in mind if you need more performance. So if you need max performance, you can get out of Java, then use the latest Java version. They will be the fastest. And then check out the different JVMs on the market. There are really differences and then sometimes huge differences. And also if you have if you deal with bigger memory sizes and complex object structure, also the garbage collector can be deciding. So you can check out different garbage collectors, and so we do performance testing and testing in general with all JVMs and all garbage collectors. So this is also deciding. Storages, yeah, as I mentioned, we have these database connectors, and then we have some rules, but Florian mentioned already. So there are only some rules, but these rules are important, and it's a paradigm change in database programming. So you have to think a little bit different. This was very famous phrase, think different. But in reality, people don't like to think different. So this is my experience. We want to do it the same way as we do it for 20 years. So what's the difference between EclipseStore and the database? On the left, you can see the traditional database server paradigm. We have a Java application, and we have a database server that runs on a remote machine, and your data are there. Your data are stored in this remote database server machine. With EclipseStore, it's totally different because EclipseStore as a storage framework runs in the same JVM process as your application logic, as your business logic, and data is stored in memory, and it's close now. It's close to your application. So as database vendors tell us, the closer the data are to your business logic, the better. So now it's the best case. We have data directly very close or closely to our application logic written in Java, and there is only a storage required. So, and you never will send this is not the server. You will not send a query to this storage. This is impossible because it's not a server. So everything is executed in one and the same JVM. Searching and filtering, indexing, everything is done in the same JVM. All right. So keep this in mind. And this is the reason why searching and filtering is so extremely fast, because it's done in the same JVM. It's done by core Java features. All right. Does the framework have a lot of dependencies? No, it has not a lot of dependencies. Only some, just a few dependencies. Biggest dependency is really the Eclipse serializer. This really, we don't need these ton of dependencies. Some month or years ago, even the Eclipse serializer was the only dependency, but Java, of course. Challenges, I mentioned already. It is a Java approach, and different to database systems. The framework should not be pretty for all programming languages on the market for all developers. No, it's built for Java. It should extend the JVM with persistence. So bringing persistence to the JVM, because this is the only thing that is missing in Java. Everything else is already implemented in Java, and it's better in Java. So we just added persistence to Java. It's built for Java developers, blah, blah, blah. It's a paradigm shift in database programming. That we saw this already. Important thing is we store objects. Previously, maybe we have used Hibernate for storing objects. Now, the great question is this a drop-in replacement for Hibernate? No, unfortunately, no. You cannot use this as a drop-in replacement. It's because of there is no relational database anymore. So it works different in the Hibernate. Mostly the object model that, or the Hibernate entity model, is also adapted to the relational model. So with EclipseStore, you can do it more granular. You can do it freely. You can build it like it's like that it fits for your use case, and it's not built around a database specific model. So this is the reason why you will build your object model different compared to a Hibernate entity model. This is also very important. Migrating from Hibernate to EclipseStore is possible, and it's not a big deal, but it's not a drop-in replacement. So keep this in mind. And I know that it's hard to accept, and people are working on a kind of drop-in replacement, and so a lot of things going on with AI, and I don't want to say it's impossible. So we're even working on that behind the scenes, but so far it is not a drop-in replacement. There is no SQL support because, of course, you cannot execute SQL on collections. This is not possible, but same here. A lot of people have this idea, and some of them are working on an SQL support for collections. So I don't want to say it's impossible. Maybe there are approaches out there, and one day it will be possible. And we also have experimented. But so far, there is no SQL support for collections. The traditional database tools are not working. The question in the chat is, are monitoring tools are provided or admin tools are provided. As I mentioned, there is a graphical user interface where you can browse through the storage data, and that's the only one. And it's because of it's just a Java library. You can use all monitoring tools that are available in Java for monitoring your JVM, because everything because EclipseStore is just the feature that stores your object graph, but everything else is pure Java. So everything is stored in memory. So it's just a JVM job, and you can use monitoring tools that are available for Java to monitor what's going on in the JVM, or it's what's going on in the memory. Yeah, it's not suited for DBAs. That's obvious. So even if you use a relational database to store the binaries persistently on disk, there is no representation of a relational model anymore. So it's stored binaries, and DBAs would be very disappointed because they cannot query now the data with SQL and creating ad hoc queries with SQL. So they don't like it. And this is also one of the biggest challenges. And it's because of, if you like EclipseStore, and we often hear this sounds too good to be true, because this is an old Java developer dream come true. We had the same idea 20 years before you started the project. That's true. And a lot of people like the concept, but they're Java developers. So you guys are Java developers. If you discuss this model or this approach with database enthusiasts, they will not believe you, and they will not like it, mostly. So this can be challenging in terms of a discussion where you discuss with your colleagues and with your management to use EclipseStore in production in a mission critical application. So they really have to think different, and they have to see the benefits. And the benefits are up to 1000x faster queries. You save 90% database costs in the cloud, and save the planet. But hey, there's no SQL, so you have to fire all the admins. No, don't. I'm just kidding, of course. They should become now DevOps, because we need more DevOps because we want to run all of these in the cloud, right? So I have to all of these stupid jokes in the evening, so I hope it's also a little bit funny for you guys. Some more questions. So okay, I like to come back to the big picture because there were already questions in terms of okay, what actually is open source, what is closed source, and so on. So we have EclipseStore, the open source project. It's a single server approach, which means it runs in the same JVM of your application. It runs on a single JVM node. So this is and everything we talked tonight about tonight is included in the open source framework. Oh, thank you for for the comment in the chat. Great. So it runs on a single JVM, but now many people think, okay, but this is really limited. So this is I cannot use it because I need a cluster or something like that. When we developed the EclipseStore, not many people, or 13 years ago, nobody talked about microservices or scaling applications in the cloud. So it was monolithic applications were everywhere. So this is very powerful, and even if you run applications in the cloud, if you do microservices, it can be sufficient in so many cases, because of we always talk about scaling applications in the cloud and horizontally scaling is super important, and microservices are important. But in reality, many applications do not need horizontally scaling, or hey, my crashed Kubernetes pod has to be started or restarted in milliseconds because my whole application will be not available. This is not true. So mostly you can split up your application into multiple services based on domain-driven design. So you have maybe an order service, you have a customer service, you have a report service. So a lot of different services. And there is a rule with microservices. So each microservice should have its own database. And so you split up your traditional database, which is always a monolithic application, a big monolith, into multiple data services. And so which means you also split up your database itself, the data itself. It's and each service will care for a smaller part of your data. And the services, like a microservice, should be tiny, micro. That's the reason why it's called microservice. It's not the big monolithic machine. So, which means if one of your services will crash, maybe you don't need to implement a distributed environment, which is super complex. Maybe it's sufficient to just restart your service. Then maybe your report service, if it's crashed, then it's not available for 10 seconds. But 10 seconds later, the report service wakes up again. It's available again, and it's accepted. So it's okay. Then EclipseStore is good to go. So it's everything you need. So this is what you should have in mind, and you should really design your system carefully, not to implement complexity, and that complexity you just don't need because it works. So we have horizontally scaling because, hey, it works. And this is the reason why in so many custom applications we have proven EclipseStore is sufficient for your use case, and you don't need anything else. You don't need a big cluster. But of course, there are a lot of use cases where we need it. So in addition to EclipseStore itself, we have now the Enterprise Edition. And why do we have an Enterprise Edition? There's also a story behind this, and it's because we have constantly explained EclipseStore as I tried to explain it the last 5 minutes. Use domain-driven design, build small services, and so on, and then a single service that has its own database won't have access to 1 terabyte of data mostly. So maybe it has access to just 5 gigabyte because you have 50 services that have access to 5 or 10 or 100 gigabyte. So loading data into memory is not a big deal for this service. So it's fast, and you can segment your data structure. That's all you need. But a lot of developers do not believe us. They say, no. In my use case, this service has access to 10 terabyte, and searching 10 terabyte or loading or preloading just 100 gigabyte into memory, it's impossible. So I run services max 8 gigabyte memory. Bigger is not allowed, so I cannot preload the whole data into memory to search with Java streams. No. And there is a lot of I/O. So imagine you have to preload data before you search with Java streams. No, I don't believe in you. No. Database is faster. All right, so this is the reason why we one day decided we need indexing, or our community or a lot of developers are keen on an indexing concept they know from traditional databases. Now we have it. And the same with it's the same with lazy loading. You tell me I should segment my collections if I have massive data sets. How should I design my collections? And this is effortful. I don't want to do that. I love your 1000x faster queries, but no, I don't want to segment my. No, give me something magic. Okay, here is it. That's the reason why we one day decided we build a collection that cares for everything. It uses indexing and it cares for fully automated lazy loading and so on. This cannot be achieved within the open source project because there we have an open source roadmap. So we create an add-on package, and this is what the new MicroStream Enterprise Edition actually is. And we will constantly add features like asynchronous write operations and so on. This is just work in progress. Enterprise Edition will be launched next week. Final release will be available with indexing and this Giga map with fully automated lazy loading. And it extends EclipseStore, which means it's another it's another dependency. This is closed source and it's fee based. So this is that's it. But to be honest, we have not already finalized the pricing model. So there are two models in discussion, and I can tell you today we will probably decide for a very simple model, which means there will be a license for a whole applications or an application license. You use it in an application. It costs $5,000 subscription. That's it. So no matter how many CPUs or memory you use, and for microservices, we will have a different model because of you can have a microservice application with hundreds of services, and this will be a little bit different, but it should be also very cheap because this is not our a product that should become a cash cow or something like that. This is just to refinance our effort in developing in additional development because 10 people working on currently full-time on this solution. And the index is really it's only needed when you really have massive data sets. Here you can really search billions of objects in milliseconds, and you really need a big database that you really need indexing. But it's convenient, of course, and this Giga map is so we are super excited about the convenience of the Giga map. So check this out, and you can test it. The open beta is already available. You just have to create an account, a MicroStream account, and then you can check it out. It's super easy. Transferring data is also okay. Like the project which synchronizes relational database with EclipseStore. Yeah. Okay. Synchronizing. This is very interesting question. I like to see a project which synchronizes a relational database with EclipseStore. I have some slides where we really do that, and it's because of we have a lot of migration projects. As I mentioned, this is not the drop-in replacement, but we are migrating together with customers a lot of applications, And migrating an application mostly does not take 2 weeks or so. So very often this is a process through many years, especially when we migrate a huge application and then we transform the application, a monolith, to microservices. So this is a process that takes many years. So we have to implement an in-memory database, an in-memory data processing system based on EclipseStore, while the legacy application is still in use, still running, and they make still business with the legacy application. And so we have to build, a new system, have to maintain the old system, and both have to be synchronized in any way. Great question, and there are different approaches. I come to this in some minutes. To flush, if there is an API, for example, to force flush or lazy loaded objects to the storage? Sure, you can do that. So there are different store methods. You can store just deltas of your object graph, just the changed objects, or you can flush the whole subgraph or the complete graph. This is also possible. Back to the enterprise services. In addition to the MicroStream Enterprise Edition, we provide a cluster solution, and this is for now really big applications, where you have to introduce distributed applications or microservices that should scale horizontally. Then you can use this cluster infrastructure. This cluster runs on Kubernetes and is available for on AWS as a managed service. And this is great service for just testing, playing around, how to build a distributed application with EclipseStore. How does it work? How does it feel? How does it really run on AWS? You can check out the performance without the need for setting up a Kubernetes cluster, and how to scale it and how to maintain it. It's just some mouse clicks and super easy. In production, most of our clients want to run this cluster on-prem in their own cloud environment or in their own data center even. And therefore, we provide the cluster infrastructure on premise. The only requirement here is Kubernetes, and then you have the cluster, can install it and run it anywhere. So for testing and checking out, for performance tests, use the service, the fully managed service. It's cheap. You don't have to maintain it. There is no DevOps effort, no Kubernetes know-how required. So it's just a single jar deployment, or you can just let the service read your pull your project from GitHub. That's super easy to deploy. For production use, as I mentioned, most of our clients don't want to run this in AWS. They prefer running in their own data center. So this is also possible. And here also, the pricing is very fair. It's based on AWS pricing, and it's today we had a meeting, so this is actually completely secret, but hey, I am CEO. I can tell you more about that. We will now start a great campaign next week where we offer the SaaS service, so the whole cluster service for free, completely for free. You just have to pay for the AWS infrastructure costs, and these costs you have to pay for anyway if you set up a Kubernetes cluster in the AWS, but you get it for just the net AWS costs, and that's it. No fees on top of that. So this is our gift for 25. And I hate these online meetings because I cannot hear the applause. Thank you for that. All right, so let's come to some infrastructure and some architecture approaches, because this is always a great discussion. How does this look like in a distributed environment, and so on. Here again is the simplest cluster approach you can imagine. So it's because of on top here you can see these boxes are services, stateless, microservices, serverless functions, whatever. Can be a monolithic application that it runs as a distributed application on multiple server nodes, and then you have a single storage services. Each service runs on a single node, on a single server machine, is responsible for specific use case, has its own storage. And here in this graphics, you can see there is a small black box in the bottom of this graphics. This is the storage actually, because this is the hard disk drive of this server node. So each service has its own storage. Simple. And if one of these services crashes, if the report service crash, we will restart it immediately. So if this runs on Kubernetes, maybe this instance can be restarted in seconds. And then it depends on how fast your JVM will start, and to accelerate JVM startup time, you can use GraalVM native images. You can use for instance instant on, which is part of Open WebSphere Liberty. This enables you to restart your JVM way faster. Also, Azul as a JVM vendor, they have pretty much the same. They call it, I've forgotten the name, but it's ready now. I guess it's ready now. So they create a snapshot of the JIT compiler state. And then if the system crashes, you don't have to warm up the JIT compiler. It's loaded into the memory, so that the last state is loaded directly into the memory, so it can really restart the JVM in milliseconds. That's great without the need for GraalVM native images. So maybe this is sufficient. So if one of your services crashes, hey, we can restart it in some milliseconds. Maybe it takes 10 seconds. This is not a problem for me, because hey, we can wait for 10 seconds, because report takes anyway 30 seconds until it's open. Then it's a great approach. You only need EclipseStore for a lot of use cases. Will be great. Okay. Then of course I have added here some other programming languages that then there's no requirement for a programming language. So you can also use Python services, .NET services, because you can communicate with EclipseStore nodes by using REST. So this is the simplest way to get access from an application or a service, no matter whether it's Java or other programming language. So you can get access to an EclipseStore application, trigger the queries, and so on, the business logic running in your services, and you're good to go. And only the services are written in Java. So, but so there might be a lot of organizations, they will tell us, no, it is impossible because we have order service, and the order service we have different loads, and we have peaks, and so this service has to scale horizontally. We have to share the load when there are peaks, and so this is super important that this service will scale horizontally. All the other services, okay, not mandatory, but please, we need horizontally scaling for this order service. Okay, then for this case, let's use a microstream cluster. How does this work? A microstream cluster provides you now an infrastructure based on Kubernetes, and this service will deploy your EclipseStore application or microservice, and will start multiple Kubernetes pods, multiple instances of your application or service horizontally. As you can see, we have one writer node. So this is a single writer approach. We have multiple reader nodes. So this is great for read-heavy applications. For write-heavy applications, this approach is also great because we can introduce asynchronous writes, but this is a different story. If there is a write request, then it's it's forwarded directly to the writer node. The writer node will store the change data into its own storage, and now will delegate the store to all the other reader nodes. As you can imagine, this approach is eventual consistency. But we have to be careful with these phrases, eventual consistency, full consistency, because on the writer node itself, the store operations, they are full consistent. They are transaction safe, and they're full consistent. In terms of the whole cluster, the approach is eventual consistency, because we have no guarantee when the store method is replicated to all the reader nodes. So we never know when the change object is merged into the object graph of a reader node. The only thing we know for sure is that the store method is executed on the writer node, and it's definitely stored transaction safe. So on the writer node, we have full consistency. On the object graph, we have full consistency. In terms of the whole cluster, eventual consistency. This is how it works. This cluster approach provides you, of course, replication, failover. If one of your nodes will crash, the cluster will automatically share the load through all the other reader nodes. And behind the scenes, it will care for restarting a new node. Then the cluster is complete again. Data redundancy, and it's because of each cluster node has its own storage copy. So data redundancy, high availability, because the system will be able to react in a specific amount of time. Elastic scaling is also a great feature. So you really can define how many nodes you want to run, and you can define a max and a min for how many nodes should be launched in the cluster. So imagine there is a peak on the order service. So there is a concert, and now, hey, the sales is open. You can now order tickets, and bam, now the order service is under pressure. Oh wow, system is in trouble. Okay, then the cluster will start more and more order services. More nodes are started, but how many nodes should be started? Maybe, yeah, because keep in mind there are a lot of machines will be launched. That's great for a cloud provider, but this will increase your costs. So you have to define a maximum of nodes to be started. So you can say, okay, I want to run at least 3 nodes constantly, and if the load goes up, start another 7 nodes, so 10 nodes max should run in the cluster. If the load goes down, then please shut down the nodes that are not required anymore. And then you have elastic horizontally scaling. So, and then you can handle the peaks, and you can save a lot of money if there is yeah, concert is over, and so now our online store so is bored, so nothing happens until we launch the next concert. Any questions? And you will get this cluster based on AWS as a fully managed service, as I mentioned, and this is a graphical user interface. It's really self-explained. It's so easy to set up a cluster, to configure the cluster, to configure also elastic scaling. You can also define when a new node should be started. For instance, if I don't want to start the next node when all other nodes are in trouble. So if the load is, or if we have 80% of load on our nodes, then the cluster should start a new node, because keep in mind it will take maybe 20 seconds or even longer to launch a new node in a cluster. Everything depends on Kubernetes and how you give Kubernetes resources. So this can sometimes take even longer to launch a new node. So you can define how the cluster should handle the load. And you will get, you can configure that with our graphical user interface. It's so easy. No DevOps know-how is required. The only thing is you have to give us your credit card data. And of course, you should know what you are doing. So keep in mind, so you start a Kubernetes environment and you add nodes. So it creates machines in an AWS data center. And so this will, this is linked to costs. And but that's it. So no more specific Kubernetes know-how is required. And if you want to run this on in your own data center, in your own cloud environment, then you just choose the on-premise version. It's also well documented, so it's easy to set up, to use even on on-premise. Okay. No questions about the cluster. Now, here we have an interesting architecture. And when we talk about EclipseStore, we talk about this is a persistence. Persistence wants to store data because this is the job of persistence. And we store data directly on disk or in a blob store. So we don't need a database anymore. But a lot of people will tell us, are you crazy? No, this is not a great approach to use this as a primary data store, because I know PostgreSQL for 25 years. Oh, it's not for 15 years or so. I have trust to PostgreSQL, but I'm new to EclipseStore. So no, we should use our database system, but I'm interested in performance. 1000x faster queries. I get applause from Repco. Thank you. So you trust more, you have more trust in PostgreSQL. So please enroll for the upcoming trainings, Repco again. Just joke. But I'm interested in the performance because it sounds really interesting, 1000x faster, and we have proven in some demos on our website. Even there is a demo that shows that Java Streams is so fast you can try to beat it with your Hibernate approach, and even if you read data directly from a local cache, forget it, will be slower than Java Streams API executed in memory. So that sounds great. Yes, you can combine it, no problem. So pick both components, combine it. That's it's possible, and a lot of customers, or more and more customers, use EclipseStore or MicroStream as a cluster, the cluster environment as a cache or distributed cache. And then you have a high performance data processing with plain Java, but you keep your object relational mapper just for storing data. And then you can keep your traditional database. Everything works as usual, and you just add a new caching layer, and then you have all advantages. And mostly at this point, the people will ask us, okay, but there are other distributed caches on the market. Where are the benefits? So all other caches on the market are key value stores, right? So and the functionality is mostly limited. With EclipseStore or MicroStream cluster, we constantly talk about you can use the real Java object model and you can build it freely. You can use a real Java object graph, all Java types. You have not to build a key value structure. So you can do whatever you like, and then you can cache it. You can execute it in memory. You don't have to care for how it's persisted. So you have all benefits of core Java, searching and filtering. Now you want to not only have your data in memory, you also, or use it for caching, fast access. No, you also want to query your data in memory. So we don't have to invent a query language because we have Java Streams API. We have persistence, so you can persist the cached objects. And by the way, we are going to launch a caching API on top of the EclipseStore API. This looks similar to what caching APIs look like. It's not mandatory, but we're going to launch it. It's because of then it fits more to the caching context. And people who use a cache already, they are familiar with caching APIs. All right. And then maybe you want to store really big data sets by using EclipseStore. You want to search and filter what you have in cache. So you have this indexing concept. So you have indexing, you have full text search. You can use it as a search server. So searching and filtering is super efficient and fast. Just core Java, and it's replicated through multiple JVM nodes. So this is, in a nutshell, the difference and the benefits to other caching approaches on the market. So okay, this slide is almost the same. So the previous slide shows maybe you have different database systems, or you just have only one database as a primary database, and you use microstream cluster as a distributed cache. If you have more trust to the storage, transaction safe storage, and everything works fine for some years, some people in your organization will ask one day, why the hell we are still using this database system? Do we need it again? Or do we actually need it anymore? No, it's because, yeah, you can use EclipseStore, and it's built for that as a primary data storage. And then you can remove your traditional database system. You can remove Hibernate. You can remove a lot of complexity. You save a lot of machines, CPU, powers, memory, and costs. But this depends on you. Okay, so whatever you like. And then there's a crazy architecture, but actually it's not crazy. Do you remember how a database works? When we have a look inside the database, we can see there is also business logic because of stored procedures, stored functions. Imagine you use EclipseStore as a cache. You just store, you query a database, and you store the result set in the distributed cache. Then you use mostly a cache for reading access because it's so fast. Great. But suddenly you think, it would be great if I can search and filter this data in memory without hitting the database, because it's faster with Java streams. Okay, yeah, we can do that. So now we use indexing, we use GigaMap. So okay, great. Okay, then what about full text search? Yeah, we can implement Lucene. Yeah, okay, now we have full text search. Okay, but we need particular logic in our cache, because of we want to, I don't know, whatever, we have some vector operations. Can we put business logic into our cache? Oh yes, but there is no specific database specific language to learn. It's now you can implement it with plain Java. You can use everything that's available in Java. Each library, all Java types, so you can implement everything. And of course, you can now implement, because we are Java developers, the whole business logic into these nodes. And suddenly, maybe there is no more need for running the business logic outside the cache. Maybe you can also run the business logic inside the cache, and then we have a plain Java application that is replicated. This is actually the use case we had in mind when we created this cluster. So write an application in plain Java, and we want now to run it on multiple server nodes. It becomes distributed with this cluster solution, and you can do that. Or you can say, no, I don't want this approach, and it's because of business logic should be run outside as separated services. They should be stateless, because these nodes are stateful. They have state, they have data in memory. Of course, this is a cache, so we want to keep data in memory for fast access. But microservices should be stateless. We only want to use it when needed, and the system should shut down when it's not needed. So we can do both. Both approaches are possible. So you have freedom, pure freedom, and everything is pure Java. No database specific stuff, no cache specific stuff, plain Java. That's it. That's so that you have, in terms of architecture, the freedom to design everything. All right, what's the time, please? So I've really forgot the time. Do we run out of time? I'm not sure. But now, last slide, almost. We had a question here in a chat, how to combine it with a traditional application. Here is an example how we migrate applications, how we can use it in an existing system. On the left, you can see there's an example for a big monolithic application. It can be a Java monolith. Very often we have Oracle applications, big Oracle applications written in PLSQL. There are a lot of applications out there. They're written in PLSQL. And then, of course, we have on the bottom, we have a traditional database, maybe an Oracle database. And now we want to migrate this to a Java application. And of course, we want to have microservices. And how should we proceed? How can we achieve a microservice environment? And how can we use EclipseStore or MicroStream cluster? So that's really really easy. So we split up the monolithic application with domain-driven design. We create services that are responsible for a specific use case, and then these services are normally stateless microservices written hopefully in Java, but maybe there are some Python services for AI. I don't know. In between, we have the MicroStream data platform for fast data processing in memory. And then we can build step by step. We can migrate step by step features of the legacy application to and port it to microservices. So maybe we create the customer services, the order service, and so on. And in 2 years, we will migrate all the report services. So this can grow and can be done constantly. And in between, we build up the MicroStream in-memory data platform for reading access, but behind the scenes, we still use the legacy application and the legacy database for storing data. And now we have to synchronize our new system, of course, with the old system. This might be the biggest challenge, right? So to implement synchronization between the systems. There, of course, this will we have not enough time for in this training, but you can use, for instance, stream processing for that. Mostly people are using Kafka for synchronizing services or applications, but also frameworks like Debezium could help you for synchronizing your database with a new caching layer built with MicroStream, and synchronizing your database with your microservices written in Java. So if you're interested in learning more about this, how we do this with current customers, if you need some new ideas, then please contact us. We can do at any time an online call, and also we provide support and training and implementation service. And this is, of course, how a microstream also creates money. So we contribute full time to the open source project, but we earn money with consulting and implementation service. So we will love to support you as we support customers today, like Allianz Insurance Company, where we build such finance services and other companies. All right, this is mostly I do the trainings with Christian, and Christian mostly say, Marcus, stop doing sales here during EclipseStore training. This stuff is open source. Conclusion, so with EclipseStore, you can build ultra fast database applications with pure Java. And I hope now you have a better overview how it works, how you can get started, what can you do actually with EclipseStore, storing your objects, build whatever you like, you can store it. It's plain Java. So EclipseStore is free. It's under Eclipse public license, which means you can use it for commercial purpose as well. Check it out. You are invited to enroll for our advanced training. We provide advanced training also for free because we want to have you in our trainings. You should learn about more about how it works in more deep to help you build awesome systems by using plain Java stuff. Please give us feedback. We are super keen on feedback. Also, if you have some concerns or what's missing, and we are super excited to hear more about your feedback. Thank you so much for joining this training. If you have any questions, I will be available for some more minutes to answer your questions. You can also should store us on GitHub. You can use GitHub discussions to ask you technical questions. We have a meetup group, and we will plan new workshops in addition to the trainings. We will introduce the latest features in this meetup group and this workshop and these sessions. So let's stay in contact, ask your questions. And for all of you guys who have to leave now, thank you for joining. It was my pleasure to spend some great time with you. Hopefully we meet at JCon. You will get a free ticket for JCon. Don't forget JCon. So thanks for joining. Have a great day or night wherever you are. Thank you for joining. Bye-bye.